In the words of Bharati Krishna, it is magic until you understand it, and it is mathematics thereafter. Now let us know values of trigonometric ratios of 90 degree. Trigonometric ratios of 90 degree. Now I am taking a right angle triangle. Right angle triangle ABC. Right angle is at B. In triangle ABC, angle B is equal to 90 degree. And I am taking measure of angle A as theta. If theta increases to reach 90 degree, then what happens? If theta increases to reach 90 degree, then what happens? In that case, when theta increases, then B comes close to A. We can observe that fact in this figure. When theta is increased some more, AC will have at some other position, C moves to the position C1, and B comes close to A. Let me write this position as B1. Here theta 1 is more than theta, and if theta 1 is increased some more close to 90 degree, then what happens? Here it is AC. In that case, this B moves some more close to A. Let me take it as B2. Here in this case, if I write this angle as theta 2 is more than theta 1, and it is more than theta. If continuous, if theta reaches 90 degree, then what happens? If theta reaches 90 degree, then B comes close to A, almost B coincide with A. B comes close to A and coincide with A. Here in this case, if theta is equal to 90 degree, here A and here is C, and B comes close to A and it's coincide, B coincide with A. In this case, length of AB is 0. If theta is equal to 90 degree, B comes close to A and coincide with A, so that AB equals to 0, and finally BC equals to AC. BC equals to AC. BC length increases and it comes close to AC. It equals almost to AC when theta increases to 90 degree, so that BC equals to AC. Based on this information, based on this result, when theta is 90 degree, let us write all 6 trigonometric ratios. Here, right angle opposite side, always we call it as hypotenuse. Theta opposite side is opposite side to theta. Adjacent side to theta we call it as adjacent side to theta. We have definition of sin theta as opposite side to theta by hypotenuse. Now we are writing with respect to 90 degree. Sin 90 degrees. Here opposite side to theta is BC. Opposite side to theta by hypotenuse AC. In case of theta is 90 degree, BC equals to AC. Here AC by AC. AC and AC get cancelled one time, so that sin 90 degree is equal to 1. Next, cos 90. Let us write cos 90 degree. Cos 90 degree is cos theta is adjacent side to theta by hypotenuse, so that AB by AC. In fact, when theta is 90 degree, AB equals to 0 by AC. 0 by AC is 0. So cos 90 degree is 0. Cos 90 degree value 0. Remaining trigonometric ratios. Tan 90 degree. Tan 90 degree is, tan theta is opposite side to theta by adjacent side to theta, that is BC by AB. BC by AB. When theta is 90 degree, BC equals to AC, so that AC by AB equals to 0 units. AC by 0. AC by 0. 0 division with 0 is undefined, so that I am writing infinite, undefined. So tan 90 degree is undefined. Here cosecant 90 degree. Cosecant 90 degree is hypotenuse by opposite side to theta. Cosecant theta equal. So that AC by BC. When theta is 90 degree, AC by BC equals to AC, so that AC and AC get cancelled one time, so that cosecant 90 degree is 1. Next, secant 90. Let's write secant 90. Secant 90 degree is equal. We know secant theta is equal to hypotenuse by adjacent side to theta, that is AC by AB. AC by AB. So that AC by AC by AB. Here AB equals to 0 when theta is 90 degree. So that AB equals to 0. We know division with 0 is not defined, so that infinite, undefined. So secant 90 degree is infinite, undefined. Finally, cot 90 degree. Cot 90 degree is, cot theta is adjacent side to theta by opposite side to theta, that is AB by BC. But when theta is 90 degree, AB value is 0. BC equals to AC, so that 0 by AC, 0 by AC is 0. Cot 90 degree is 0. As a tan, we have tan 90 infinite and cot 90 value 0. These are the sin 90 degree 1, cos 90 degree 0, tan 90 degree infinite, cosecant 90 degree 1, secant 90 degree infinite, undefined, cot 90 degree is 0. These are the trigonometric ratios of 90 degree. If we take triangle in its standard position, that means if we take that angle onto the coordinate axis, we can understand trigonometric ratios of 90 degrees easily. Here I am taking this angle AOB onto the coordinate axis. You know, horizontal reference line is called x-axis. Vertical reference line is called y-axis. Intersecting point of x-axis and y-axis is origin O. If we take this angle here, if we take initial side along x-axis, vertex as origin, that means OA is along x-axis, positive x-axis, and position of OB is here with angle theta. Here, if theta is increased to 90 degree, we need to find trigonometric ratios. Let me take a point P, xy. By taking, let me take the length of OP is as R, OP as the radius, R as the radius, O as the center. I am going to draw a circle so that when the angle is increasing, we can understand position of P well. If theta increases to 90 degree, then what happens? When theta is increased, P position moves to P1, then to P2, like. At initial position, when angle is theta, P is xy. That means foot of the perpendicular, if taken as Q, PQ is y. Distance from x-axis to a point is called y coordinate. Distance from y-axis to point is x coordinate. So here to here x. So here to here the value is x. If theta is increases to P1, if theta increases to theta 1, then Q moves to Q1. If theta increases some more, then Q1 moves to, foot of the perpendicular moves to Q2. When theta increases to 90 degree, Q moves close to O. And coincide with O. At the case OQ equals to 0 units. And PQ is increasing. PQ less than P1 Q1 less than P2 Q2 and so on. Finally it moves to y-axis. That means P moves to this position for some Pn. At that case, it is also Pn also is nothing but R. So PQ equals to OP, that is nothing but R. OP equals to PQ, that equals to R units. If theta is equal to 90 degree or pi by 2 radian, theta is pi by 2 radian. As I took in circular measure pi by 2 radian, 90 degrees pi by 2 radian, then Q coincide with O, so that OQ is equal to, OQ is nothing but x, that equals to 0. 0 units, and PQ equals to OP, that equals to R. PQ equals to OP, that is R units. Based on this result, we can write trigonometric ratios, all 6 trigonometric ratios. First of all, let us write sine pi by 2 radian, sine 90 degree. We know sine 90 is y coordinate by r, y coordinate by r, y by r. Here y equals to r. OP is, PQ is nothing but y, that equals to OP, that is y, that equals to r. As PQ is y, that equals to r. So PQ equal to OP, PQ is nothing but y, OP is nothing but r. So y equal to r, r by r in r cancel 1 times, so that 1. Sin pi by 2 radian is 1. Next, cos pi by 2. Cos pi by 2 is x coordinate by r, that is x by r. When theta is pi by 2 radians, in that case x is 0 units, so 0 by r is 0. Cos pi by 2 is 0. Next, tan pi by 2. Tan pi by 2 radian is y coordinate by x coordinate, that is y by x. So that here y equals to r by x equals to 0. So that r by 0 is undefined. So tan pi by 2 radian is undefined. Next, cosecant pi by 2. Cosecant pi by 2 radian. Cosecant pi by 2 radian is r by y. R by y, r by, we know y equal to r in case of theta is 90 degree or pi by 2 radians. So r in r get cancel 1. So that cosecant pi by 2 radian is 1. Next, secant pi by 2. Secant pi by 2 radian, r by x, that is r by x according to definition, r by, here x equals to 0, so that when theta is pi by 2, r by 0 is infinite, undefined. Secant pi by 2 radian is undefined. Finally, cot pi by 2. Cot pi by 2 radian is, cot theta is equal to x by y, x coordinate by y coordinate. That is, we know x is 0 and y is r. 0 by r is 0. 0 by r is 0. So cot pi by 2 radians is 0. So from this we came to know when theta is 90 degree, co-point Q coincide with foot of the perpendicular from P is Q, that coincide with OQ is 0, that is x is 0, and PQ coincide with OP when the angle is 90 degree, that is nothing but R. So y equals to R. So that from this we came to know sin pi by 2 is 1, cos pi by 2 0, tan pi by 2 infinite undefined, cosecant pi by 2 is 1, secant pi by 2 infinite undefined, and cot pi by 2 0. These are the trigonometric ratios of 90 degree.